Hello guys, and welcome to this OCR AS-level Chemistry A paper, Breadth in Chemistry 2016 version. Right, so first question is, which row shows the atomic structure of this chlorine ion? So the chlorine atom has this atomic number and this mass number. Right, so we're going to know if this is an ion with an electron added, the electrons are instantly going to go up to 18. So the answer is obviously B. However, to double check it, or triple check it in this case, we're going to check the proton number. This is the proton and electron number. However, if electrons are added or taken away, this would only affect the electron number. So the proton number is, in fact, still 17. So the answer is either A or B in this case. And now neutrons are always going to be the mass number minus the atomic, regardless of electrons added or taken away. And so you're quite sure that the answer is B. Question number 2 is, what is the formula of ammonium sulfide? Right, ammonium is NH4+. And sulfide is the ion of sulfur. And so it's in group number 6. And so it's S2-. Right, to balance out the charges, you need 2 of this and 1 of that. And so the answer is C. Right, question 3 is calcium nitrate. Nitrate decomposes when heating as shown below. So student decomposes this amount of moles and collects the gas produced. Right, make sure you check that there are 2 gas products produced, and so to calculate the volume that a student should expect to collect, measured at room temperature and pressure. Right, so the mole, calcium nitrate is 1 mole to 1 mole to 2 moles to half a mole. So the gas produced is 2.5 moles of gas in total produced, and this is 1 mole. So you're going to do 2.5 times by 0.005, and this is 0.0125, right? And so you know that this equation, you should hopefully know that the number of moles is equal to volume over 24 decimeters cubed, or 24,000 centimeters cubed. To get volume, you do number of moles times by 24, so the volume is 0.0125 times by 24, which is equal to 0.3. That's 0.3 decimeters cubed, which is equal to 300 centimeters cubed. And so the answer is D. Okay, question number 4 is asking which equation is not a neutralization reaction. And so you should know for neutralization, it's a base plus an acid in the reactant side. So you can easily cancel out B because that's an acid and that's a base. Now, going back in order, A, this is a metal and an acid. So this could possibly be an answer because it is not neutralization. Right, for C, you got carbonate, which is a base, and then you got nitric acid, which is a salt, and so cancel this out because it is neutralization. Going to D, you have ammonia, which is a base, hydrochloric acid, which is a salt, cancel that out, neutralization once again, and so A is the answer. Right, 5 is, what is the oxidation number for nitrogen? Okay, so we're going to go to oxygen. We know that the number is -2, or 2-. And so there's 3 lots of it, so times it by 3, that's 6-. And in brackets, there's a 2 outside, so times it by 2, that's a 12-. Right, going to magnesium, magnesium is in group 2, so it has a 2+ charge. So 2+ charge, and you've got 12- charge, so 2 minus 12 equals a -10 charge. Remember, the 2 applies to both the oxygen and the nitrogen. So divided by 2, you have a 5- charge. So in order to equal that out, nitrogen has to be a +5 charge. So the answer is C. Number 6 is how many orbitals are occupied by the silicon atom. Right, orbitals are very important. And so the silicon has 14 as its atomic number. And so, right, we know the numbers 1s2, 2s2, 2p6, 3s2, and 3p2. And so these are the orbitals. Okay, these are actually crucially important. This is a very rare question to get correct. And so this is, 2, the 2 electrons. This is 2s2, this is 2p6, and then 3s2, and then 3p2. So the orbitals that have been occupied are 1, 2, 3, 4, 5, 6, 7, and 8. So the answer is C. Okay, number 7 is saying that a dot and cross diagram for nitrogen trichloride is shown below, which row shows the correct shape and bond angle in this molecule of nitrogen trichloride. Okay, so we can see there are 3 bonding pairs and 1 lone pair. And so from deduction, we could know from the basics that 3 bonding pairs is tetrahedral, so cancel that out. And 3 bonding pairs is trigonoplanar, cancel that out. We're left with 2 pyramidals. We should know it's one of A or B because there is 2 of them, so it's most likely going to be one of the 2, but we can't really be certain. And so we have 3 bond pairs and 1 lone pair. Right, which angle is it? So it's going to be 107 because 2 bonding pairs and 2 lone pairs, there's going to be more repulsion because the lone pairs repel more than the bond pairs. So it is currently as 1 lone pair, it's B with just 107 degrees. And so question 8 is, what is the shape around the carbon atoms in graphene? Right, graphene has the same shape as graphite, and so this is how it looks. But you should know these bonds repel just as much as these. So they are actually equal, repelling only 120 degrees. And so it would be trigonoplanar, and D would be the answer. Okay, question 9 says the electron configurations for atoms of different elements are shown below. Which electron configuration represents the element with the largest first ionization energy? That means the first electron removed. Right, so for the first one, this is 1s2, 2s2, 2p6, 3s2, 3p6. The 6 shows the maximum number as well as the 2s. And so for the first one, you have these 2. Right, they are close to the nucleus, and however there is a bit of repulsion because there are 2 electrons in one orbital. So question mark on this one. Right, okay, so the second one is 1s2, 2s2, 2p4. Okay, 1, 2, 3, 4. Right, if you were to take off an electron, this would be there would be a repulsion from this electron taken away, and it would be further from the nucleus, so it would be easier. So it would not have the largest first ionization energy, so it would not be B. Okay, and now we're going to look at C. And so 2p6, right. 1, 2, 3, 4, 5, 6. And so this is even further from the nucleus, and there is repulsion. And so it would definitely not be C because the ionization energy would not be the largest. If we look at D, it goes to 3s2. Okay, so that's even further from the nucleus as well as repulsion. And so the obvious answer would be A because it's closer to the nucleus, and they all have repulsion, so that's not a factor to bear in mind. So the answer is A. Question number 10 says successive ionization energies of 4 elements in period 3 are shown below. Which letter could represent magnesium? Right, magnesium has 12 electrons in total. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So after 2 electrons, you should see a larger jump because you're moving to a smaller radius and it's closer to the nucleus, so there's more of a pull. And so between 2 and 3, the greatest jump is obviously B. So the answer is B. Okay, number 11 shows a student adds aqueous sodium carbonate to one test tube and aqueous silver nitrate to a second test tube. The student adds dilute sulfuric acid to each of the test tubes. Right, I've written both equations here. Okay, so which row has the correct observations? So for the first equation with sodium carbonate, we can see that a gas has been produced. So effervescence is seen. And so, yeah, these equations have to be memorized, by the way. And so it's either between C or D. So you either see no change or precipitation formed with aqueous silver nitrite. Okay, so with the answer, you do see a solid has been formed. And so there has been a solid in the reactant site. However, this is soluble in water and this is very slightly soluble in water. And so the answer is D. Okay, question 12 says the enthalpy change of formation of butane can be calculated using the enthalpy changes of combustion below. Okay, so the calculate the enthalpy change of formation of butane. So there's 4 lots of carbon. Carbon is here. Before everything, it does say combustion, so the arrows go up. If it's formation, the arrows go down. And so carbon is minus 394. However, there is 4 lots of carbon, so it's 4 lots of minus 394. And then hydrogen is minus 286, but there's 5 lots of hydrogen, so 5 times minus 286. And then minus 2877, there is no number in front of butane. And so you go from opposite the reactants to the products. And so you're going against the arrows, going down against the arrow with the reactants and with the arrow for the products. So 4 times minus 394 does equal minus 1576. And 5 lots of minus 286 is minus 1430. And this, you're going with the arrow, and so minus 2877. 77. You are going against the arrow, so these negatives do turn into positives, in fact. And so you get 1576 plus 1430 minus 2877. And that gives you an answer of minus 129. And so the answer is B. Just for you to bear in mind, if this had a 2 in front of it, and this had the formation of just 1 of butane, then the answer would be divided by 2 in order to get the actual answer. But in this case, it's 1, 1, and so the answer is B. Right, 13 says the skeletal formulae of 4 alcohols, E, F, G, and H are shown below. Which pair of alcohols are structural isomers of each other? Structural isomers mean the structures are different. They have the same molecular formula. So you have C, 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 C. So you have 5 carbons, C5. And then the hydrogens, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. H12, and you have 1 oxygen here, O. Right, this one has 1, 2, 3, 4, 5, 6. So you have C6. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So H14, and you have the 1 oxygen. Right, these are the molecular formulas, so it's easy to write them like this. G is 1, 2, 3, 4, 5. You have C5. H's are 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. Because this carbon already has 4 bonds. And so H12. And the oxygens are 1, O. So you can easily see that E and G over here would be the answer. E and G, it would be B. But just in case, let's try H. You have 1, 2, 3, 4, 5. You have C5. H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. And you already have an O. No, this doesn't go with anything. So E and G would be the answer. And it will be B in this case. Question 14 is asking for the name of the following compound. To name a compound, you first look at the longest carbon chain. In this case, it would be 4. Or you can look at it this way, but the first way would be easier. And so we need to look at the things that have been attached to the carbons. So first, let's take a look at chlorine. You have 2 chlorines, and we start. Now we're going to see which do we name as carbon number 1, this carbon or this carbon. To know which one to name, you look at the one that's been attached to non-hydrogen compounds. And so this carbon is attached to another carbon, which is attached to a methyl and a chlorine. Both this methyl and chlorine have to be named. And so to name them, you say they're on carbon number 2, rather than saying this methyl is on carbon number 1, 2, 3. You say this methyl is on carbon number 2 to make the numbering less and make it true. And so we start with this chlorine, these 2 chlorines, and they're on carbon number 1, 2, 3, and this is 4. So you have 2, 3, because there are 2 chlorines, you say dichloro. And then if we're going to name the methyl, it's 2-methyl. Right, to put it all in an entire word, you pick between the lowest alphabetical order, and so it's D and then M. So you have 2,3-dichloro, 2-methyl, and this entire compound is 4 carbon atoms long, so it's butane. And this would be 2,3-dichloro, 2-methyl butane, it would be C. 15 is asking for the compound that has non-polar molecules. So we can instantly, this is a very good trick, cancel out C and D. And that is because Z stands for zusammen, so it means on the same side in German. People remember it as on the same side because they all begin with Z, and so they think it's easier to remember like that. And E would just mean the opposite of Z, so E is on opposite side. C and D for Z is on the same side, so just cancel it out. Because if you were to look at it like this, if these were on the same side and they produced a pole, a little charge, they would not be able to cancel each other out. However, if they were opposite, they would be able to cancel each other out. So, if we would draw them out, it's butene. So it'd be 1,2-dichloro. There's 1. There's 2-dichlorobute 2-ene. The ene double bond is on the second carbon. And if we were to draw it out like this, there would be a hydrogen here. This would be CH3. There would be another hydrogen here. So it'd be H, CH3. You can instantly see that does not cancel out because this would be there's another H there. CH2Cl, but they are on the same side. So how are they able to cancel each other out? They cannot. So you can just tell the answer is B. But to double check, let's draw that out. Bute, so 4, 2-ene, second carbon, 2,3-dichloro. Cl is here and Cl is here. If we were to draw this out, this would be Cl, CH3, CH3, Cl, and they'd be able to just cancel each other out. Right, 16 has this displayed formula for a hydrocarbon. And so it's asking for how many sigma and pi bonds are present in a molecule of this hydrocarbon. Right, sigma bonds, are for carbon-carbon double bonds, and pi bonds are for carbon-carbon double bonds. But pi bonds and sigma bonds go with a carbon-carbon double bond. So if we count the sigma bonds, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 sigma bonds. Pi bonds, there are 2 pi bonds. So the answer is D. People don't really remember that there are sigma bonds as well as pi bonds with carbon-carbon double bonds, but there are. Question 17 says chlorine reacts with 1-chloropropane in the presence of ultraviolet radiation via a radical substitution mechanism. Which equation shows the propagation step in the mechanism for this reaction? So just note, initiation is 1 step, propagation is 2 steps, termination is 3 steps. Okay, the first step, Cl2, is going to form 2 lots of chlorine-free radicals. And so this chlorine-free radical would go and react with a non-radical. And so cancel out A, that is initiation. And so you have this chlorine-free radical, because it's from this answer, from the initiation process. And that goes and reacts with a non-chlorine, so a non-free radical, And so cancel B and cancel A. And so it's either between C or D, same thing. So you look at the answers now. You should know, with a rule of thumb, with these reactions, a hydrogen-free radical would never be formed. And so D would be the answer. Okay, so this question is asking for which alcohol can be oxidized by K2Cl2O7 and sulfuric acid to form a ketone. Right, to form ketones from this oxidation, you should know they're secondary alcohols. And so this is a primary alcohol, this is a secondary alcohol, this is a tertiary alcohol, and this is a primary alcohol. And so the answer is B. And so you would also know that this is an answer that it's not a primary alcohol because tertiary alcohols cannot be further oxidized. Primary, there's 2 of them for a reason, so the only thing that's left is B. 19 is saying that a reaction sequence is shown below. So which type of reaction mechanism is involved in each step? Right, you have a H coming here and a Br coming here. It's making one product. And so this is highly electron dense, and so it's electrophilic addition because you're adding these to here, so it's electrophilic addition. And so it's either A or B. Now with step 2, you have a substitution going on, and you have the Br coming out and the OH coming in, right? If we were to draw this out over here, you have a H and you have a Br. The Br would pull the electrons slightly negative, the carbon would be slightly positive, and the the sodium hydroxide, the OH minus, would come in. And so the arrow is supposed to be drawn from actually the negative. And so in this case, the hydroxide is coming into the slightly positive carbon atom rather than this negative charge over here. And so it would be nucleophilic substitution rather than electrophilic. And so with B being the answer because you do have this in step 1 and this in step 2. Question 20 says, when heated with sodium hydroxide, 1 iodobutane is hydrolyzed at a much faster rate than 1 chlorobutane. Which statement explains the difference, the different rates? And so iodine is larger because it's more down the group than chlorine. And so just bear that in mind. Iodine, chlorine. So the Ci bond enthalpy is greater than the CCl bond enthalpy. No, it's actually not, because the carbon would be closer to chlorine and it will be much further to the iodine. And so it's greater in the CCl bond and not in the CCl bond. B says the Ci bond is less polar than the CCl bond. That is also not true, as this chlorine is closer to the carbon, so it's more likely to pull the electrons closer than the further away iodine will. And so the C is saying the Ci bond has a carbon atom with a greater slightly positive charge than the CCl bond. That is also not true, because it again relates to B. If the chlorine is pulling the electron closer, the carbon would be more positive in this rather than that. Okay, and then D is saying the Ci bond requires less energy to break than the CCl bond. That is true, because the CCl bond is actually, if you look at it, it's further away than just the CCl bond. So it's much easier to just break this bond. And so D is the answer.